Okay, so let's see if this works. We are going to find the cosine of alpha minus beta. We are deriving an angle difference formula for cosine. What we're going to use to do this is the top half of the unit circle and two congruent isosceles triangles. So we're starting off with a big angle. I want to make that angle obviously big, so I made it obtuse, and so it goes into the second quadrant. We're going to call that one alpha. So here's our first thing. Angle alpha, lovely. Now what we're going to do is we're going to find a smaller angle, which we're going to call beta. I'm just going to put a point on the unit circle, and then I'm going to measure that arc and put that arc coming backwards from alpha in order to get alpha minus beta. And that's what we're going to be looking for. And this pen is out of ink. I don't think I'm going to use it now. Let's try the blue. Much better. Okay. So this arc length here, this is the unit circle, so the arc length is the angle. That's alpha, right? So I'm going to bring alpha back from here and put a dot right here, all right? Now I'm going to draw this little thingy here to get to us. Here we go. So alpha is the big thing. That's beta's right there, okay? And when we go to this, I got to get to it. That angle that we have is alpha minus beta. Okie dokie. Now, the fun part here is going to be connecting some dots. We're going to connect. This one's out of ink too, so, that's good. Missed again. Here we go. That line segment there is the base of an isosceles triangle with a vertex angle of alpha minus beta. And that line segment right there is the same thing. It's the base of an isosceles triangle with a vertex angle of alpha minus beta. Oh, and legs of 1, because it's the unit circle, so all of these are 1. So that means that this equals this, okay? So we're going to use the distance formula on this, but first we've got to put some points in. We know that this one here is the point 1, 0. Okay, this here is sine alpha, cosine alpha, actually cosine alpha, sine alpha, because x values are cosine values and y values are sine values. This one here is the subtraction problem, cosine alpha minus beta, sine alpha minus beta. And this one here is the cosine of alpha and the sine of alpha. Yay. So we're going to use the distance formula. The distance formula is just the Pythagorean theorem. I am not going to put the square root brackets and all that. I'm going to say that the square of this length and the square of that length are equal to each other. So I think what we'll do is we'll put the one that has the alphas, mistake. There's a mistake. The small angle is beta, not alpha. The big angle is alpha. The small angle is beta. That's why this is alpha minus beta. There's a mistake. This is not cosine alpha, sine alpha. This is cosine beta, sine beta. See if everything else makes sense. Alpha, alpha, 1, 0. 1 is x, right? Okay, good. Beta, beta, alpha minus beta, and cosine, cosine, cosine. Okay, cool. Everything's in order and all that. All right. So here comes the distance formula, which is the, we're going to put the x values first and then the y values next. So the cosine values and the sine values, and we're going to subtract them and stuff. I'm going to do this line segment first and that one second. Okay, so the length of that is going to be the square of the difference of the x values plus the square of the difference of the y values. So it is going to be that cosine alpha minus cosine beta, the quantity squared, that's the vertical displacement, all right, plus, sorry, that's the horizontal displacement. The vertical displacement is going to be the sine. Same order, sine alpha minus sine beta, the quantity squared. And what that's going to be equal to is that distance right there. Again, the horizontals, it's cosine alpha minus beta minus 1. Got to put parentheses around that because that's the whole angle we're taking the cosine of. And square all of that. Plus the vertical distance here. Now, because that's a 0, I can just put in sine alpha, sine minus beta. There's no mistake up here. I'm missing a closed parentheses on this ordered parent. Open parentheses, x value, y value, close parentheses. So, man, this is a really great video. I'm great, aren't I? All right. So, last part is simply sine squared of alpha minus beta, because subtracting 0 is doing nothing. So there we go. All right. So we're going to FOIL a bunch of stuff and expand all of this. I'm going to write real small for this. You might have to zoom way, way, way in. See it. But this is cosine squared alpha minus 2 cosine alpha cosine beta plus cosine squared beta. Yay! All of that is expanded right here. Okay. This will be with sines plus sine squared alpha minus 2 sine alpha sine beta plus sine squared beta equals, see if we can fit it all in, all that squared, cosine squared alpha minus beta, okay, minus 2 cosine alpha minus beta plus 1. And then plus sine squared alpha minus beta. Yippee. Now the fun part here, everything's fun. I bet this red one has no ink in it at all. We'll find out. Is that the Pythagorean identity is all over the place here. So what I'm going to do is I'm going to find the cosine squared alpha and pair it with the sine squared alpha, and that equals 1. So cosine, yeah, of course, none in this. That's great. I guess we're back to orange. All right. So it's cosine squared alpha right here, which I'm going to underline this way, and that sine squared alpha. Those two are going to add up to 1. Right? This cosine squared beta, which I'm going to squiggle underline, will pair up with this sine squared beta, and that'll equal 1. Okay? This cosine squared alpha minus beta, I'm going to pair with the sine squared alpha minus beta, and that equals 1. And this 1 right here, that equals 1. So what I'm going to do is I'm going to subtract 2 from both sides. There's 1, there's 1, that's 2. There's 1, there's 1, that's 2. Subtract 2 from both sides, all those things go away. What we're left with is, actually, so I'm going to just cross them out because they are going away, okay? They cancel, all right? So bye, 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 bye. And you'll notice everything left, this term, and this term here, that's all that's left. All of those, I'm going to go ahead and just kind of box them so that we can actually see them here. All that remains, I'll go this away and keep out that plus because that one already got canceled out of here. Every single one of these has a coefficient of -2. Negative 2 here, -2, and -2 here. So a moment ago I just subtracted 2 from both sides to get us down to this. Now I'm going to divide both sides by -2. But you're going to take those coefficients away and leave us with this. Cosine alpha, cosine beta, plus sine alpha, sine beta is equal to the cosine of alpha minus beta. And we're done. That's what it is, okay? Just turn this around and you get that the cosine of the difference of two angles is equal to the product of the cosines plus the product of the sines. That's what it is. It's this pretty simple thing. So cosine alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. That's the solution. Let's take this for a little ride and see if that actually makes sense, because we know that pi over 6 is equal to pi over 2 minus pi over 3. Now, I say we know this. Maybe we have forgotten. Let's find out, okay? So pi over 6 equals 3 pi over 6, which is pi over 2, minus 2 pi over 6, which is pi over 3. 3 minus 2 is in fact 1. Yes, that checks out. So we also know that the cosine of pi over 6 is radical 3 over 2. So let's give a shot to putting these things in and find that the cosine of pi over 6 is the cosine of pi over 2 minus pi over 3, bracket that because that's a single angle, which according to our formula is going to be the cosine of pi over 2 minus, times, you know what, just a little back there, times the cosine of pi over 3, because we have our two angles, alpha and beta, plus the sine of pi over 2, because pi over 2 is alpha, times the sine of pi over 3. Yippee! Let's do some work. Cosine of pi over 2 is 0. Cosine of pi over 3 is 1/2. Doesn't really matter because we're multiplying it by 0. Plus the sine of pi over 2 is 1. And the sine of pi over 3 is radical 3 over 2, which equals radical 3 over 2. Cosine of pi over 6 is radical 3 over 2. Cosine of pi over 6 is radical 3 over 2. Yippee! But now let's do something new with it. We're going to find the cosine of pi over 12. That's not on the unit circle, okay? Pi over 12 is pi over 3 minus pi over 4. It's pi over 2 minus pi over 3. So we can try this a couple of different ways. Make sure we're right on that. Pi over 3 minus pi over 4, that's going to be 4 pi over 12 minus 3 pi over 12 is pi over 12. So the cosine of pi over 12 is going to be the cosine of pi over 3 times the cosine of pi over 4. Those are the two angles that we have here, right? Maybe I should scoot this over, and we'll get that the cosine of pi over 12 is equal to the cosine of pi over 3 minus pi over 4. So it's the cosine of pi over 3 times the cosine of pi over 4 plus the sine of pi over 3 times the sine of pi over 4. Plug our numbers in that we know from the unit circle. That's 1/2. That's radical 2 over 2 plus sine of pi over 3, that's radical 3 over 2, times the sine of pi over 4, which is radical 2 over 2. Okay, we got 2 times 2 in both these denominators, so our overall denominator is simply 4, and this is radical 2 plus radical 6. I'm going to turn those around to put the 6 in front. Radical 6 plus radical 2 all over 4. Lovely. You will find that if you want to find the cosine of, oh, by the way, pi over 12, let's think about this as if we've got a little bit of a unit circle going on here, okay? That pi over 6 is about here. Pi over 12 is about here, okay? Now, pi over 3 is about here. 5 pi over 6 is way up. 5 pi over 12. So, does that make sense? Yeah, 5 pi over 12 is right there. I'm going to leave this to you to do the examples and figure out what all the other values are. If you want to send me a message and ask about, hey, what are these things? I'd be happy to respond to that. But I'm not going to do every single thing for you because it's too boring. The point here is that there is a 5 pi over 12 is there, pi over 12 is there, and that's it. Because 2 pi over 12 is pi over 6, 3 pi over 12 is pi over 4, 4 pi over 12 is pi over 3. So you only have these two new ones. I'm going to give you the answer to this one, but I'm going to say you work it out yourself. But the cosine of 5 pi over 12 winds up looking a lot like this. Instead of being an addition problem, is a subtraction problem. It's radical 6 minus radical 2 all over 4. And I will point out right here that 6 times 2 is 12, right? 6 minus 2 equals 4. And 6 times 2 is 12, 6 minus 2 equals 4. You might recall that we did the pi over 5s, and that the cosine of pi over 5 was radical 5 plus 1 all over 4. I'm going to call that 1 a radical 1. Radical 5 plus radical 1 over 4. Well, Well, 5 times 1 is 5, 5 minus 1 is 4. There's a similar pattern taking place in the cosine values for pi over 12 as there is to the cosine values for pi over 5. The idea here is we are finding more angles than just the 16 on the unit circle. Once we have this done, these over 12s, we can start making other manipulations and finding angles. We start cutting things in half instead of using subtraction, using division. We can start working with pi over 24. Then we can do pi over 48. Then we can do pi over 96. Pi over 96 is going to be essential for actually finding the estimate of pi the way Archimedes did it. That's where we're headed with this content. I hope this makes sense. I hope this video works. And if you have any questions, please contact me. Thank you very much.